Hello, I'm Naisaergik of Class 12, DAV Public School Unit 8, Bhubaneswar, Odisha.
And I'm Santrupti, a Class 12 student of DAV Public School Unit 8, Bhubaneswar, Odisha. And we are here to represent our innovative idea, a pectinized and tapioca integrated PAA superabsorbent polymer matrix implanted with natural pesticides and fertilizers as a cost-effective alternative to agrochemicals.
The father of our nation, Mahatma Gandhi ji, had said that India resides in villages. It has been more than 75 years since we have become independent, and India proudly we are an agrarian economy. What happens is a majority of Indian population is involved in agricultural activities, but till date agriculture has always been a welfare state. It has not been able to become an industry. The reason is we are lacking in technological advancements. We are facing different challenges due to climate change, due to many other problems. We are facing a lot of problems, but we are not able to find out a practically possible on-field solution towards it, and we are not accepting those solutions in our daily routine practice of agriculture. So what we think is, with the application of technology in agriculture, and that is with direct applications on field, we can change this scenario. We definitely, it's not a one-man job, but we are definitely through our project trying to make things better in the cases of upland variety rice cultivations, which holds a very big amount of cultivations in India.
It is a well-known fact that agriculture is the prime source of income of majority of people. But 86% of the farmers in India are marginal farmers. Overpriced seeds, expensive chemical fertilizers and pesticides do not complement their meager earnings. And this is the core of the many problems faced by increasing number of farmers committing suicide. From 1995 till date, over 3 lakh farmers have committed suicide. Today, agriculture has become a chemical intensive model solely driven by external outputs, which are actually deteriorating the environment. Once known to be the food ball of India, today northern plains have been heading towards desertification, with Malwa region of Punjab being tagged as the cancer capital, owing to its maximum consumption of pesticides in the state. Farmers involved in rice cultivation in India believe that standing water keeps away pests and weeds, but studies in West Bengal and Odisha have shown that standing water of more than 10 cm height causes heavy leaching of soil nutrients, with most of the water being wasted in deep percolation or seepage through the soil. India is the second largest producer of rice crops, but rice consumes around 15 to 16,000 litre of water per kg paddy produced. This is highlighting the alarming depletion of water resources, with India being tagged as a water-stressed country with only 1544 meter cubic per capita water availability. If such practices still prevail in farming practices, then the day is not far when India will be declared as a water-scarce country. The need of the hour is proper management of water resources and usage of pesticides and fertilizers which retain soil's nutritional values and do not deteriorate the environment. For this, we prepared a matrix which constituted of 2 parts. The first part was a mixture of wood ash and banana peel extract. This was to be immobilized in a pectinized and tapioca integrated polyacrylic acid polymer. Together, they acted as an excellent absorbent polymer. The banana and wood ash extract replenishes the soil with nitrogen, potassium, phosphorus, which are essential plant nutrients, and tapioca extract and pectin present in the superabsorbent polymer act as great pesticides by keeping away aphids and ants.
So now we had a wonderful matrix, we knew, and we had an immobilized matrix. So what we wanted to do now is we wanted to test on field whether it is really applicable and what is its efficiency on field. So what we did was we started to do a randomized field trial with rice plants of upland variety. That is, we took the variety Khandagiri and took some potted plants in a controlled condition in a space in our school, and we did the experiment. And in the experiment, what we did was we took control, that is, in general conditions it was grown, and then we gave our polymer treatment, and then we grew the plants. So what happened was, when the plant was grown with treatment, we saw growth in several parameters. like the plant height increased by 25.7 percentage. There was an internodal distance increased by 32.9 percentage. These things, the plant height and internodal distance increase, showed that there was an increase in phytochrome A and phytochrome B signaling. Then we had panicle length increase by 25.8%. We had harvesting index increase by 26.5%, and we had number of tillers increased by 20%, which showed that overall growth of the plant was also very good. So which made us believe in our matrix, and we came to a conclusion that yes, this matrix can be actually tried in a pilot scale on field, and can, if successful on a pilot scale, can be actually used by the farmers while growing plants.
In this project, I took into consideration different chemicals, for an instance, crushed tobacco leaves, crushed orange pills, wood ash, and banana peel paste. And then I tried which one was acting as the best pesticide as well as fertilizer without affecting the soil's nutritional value, and finally concluded that equimolar concentration of wood ash and banana peel paste was acting as the best measure for this polymer.
And in this project, I took up the charge to immobilize this solution so that it can actually be utilized in the field. And to immobilize, I tried taking different chemical grafts and then adding different natural polymer substances like coir, like banana peel, and then finally came up with the PAAC grafted natural polymer. And then together we did the field trials to get obtain the results. In near future, what we are planning to do is, as we have got successful results in pot scale, we are trying to go ahead with a pilot scale model with at least 5x4 replications, so that we can get a significant data and we can actually prove our statement. And then we are also trying for larger field trials, so that we can get what are the new challenges that are coming, how we can modify this more. And we are also considering about how we can increase the folds of the polymer. Like currently we are having this at around 300 to 400 folds, and we are considering with what modifications we can give it more water absorbing capacity, more nutrient absorbing capacity, and increasing it in turn increasing its efficiency. So we are planning to work on it.
Thank you.